Thank you, everyone, for coming. I'm Scott Ford, and today I'm going to talk to you about measuring dependency freshness using a metric called LibYear. So hi, like I said, I'm Scott, and I love to fix bugs, like not just a little bit, but a lot. Like I really, really love to fix bugs. So much so that I've built a company that focuses exclusively on working with existing software systems. And I also enjoy upgrading dependencies. Keeping things up to date is just something I consider to be like a lot of fun. And for a while, while I thought dependencies were really important, I never really pushed my clients too hard about them. We would push hard when we knew there were security vulnerabilities, but out-of-date packages were just kind of seen as less important. And figured if something was a year or two out of date, it wasn't a huge deal, and figured the clients would just upgrade when they were ready. But then I read this. The Equifax breach happened, and as I dug into this breach and learned more about it, I learned that it wasn't like somebody like broke in and someone on the team left bad code behind, and this bad code was exploited, and that was the security vulnerability. No, the vulnerability was that they were using Apache struts, and the version they were running was out of date, and they had a known vulnerability, and that known vulnerability was 2 months old. And had they updated, then this vulnerability this breach could have been avoided. And like, I don't mean to like disparage this team. I imagine like they're super well-meaning. I imagine they have fantastic talent. I've worked on many teams where we would have let something like this go, and so I don't want to make it sound like I'm disparaging this team. At the same time, I do think that this breach was completely preventable, and I think we can look at this breach as a lesson for how to keep these events from happening in the future. So why does this happen? Why do vulnerabilities creep in and dependencies get left unpatched for so long? So one aspect is fear. We're afraid that if we upgrade, that bug's going to creep into our system. That something we used to depend on working something we used to depend on working will stop working. Time is also a factor. We're worried that the amount of time it's going to take to do the upgrade is going to eat into other activities that are important. And then that kind of gets into the priorities and how maintenance is not seen as something that's as important as the other activities on software teams. Features are seen as much more important. Other activities are seen as much more important than doing dependency upgrades. And the perceived difficulty is also there. The amount of work that's required to do these updates it's non-trivial. It's definitely something that is a challenge. So it's something that people do need to pay attention to and kind of develop this as a skill. And the problem itself is kind of invisible. The system's working from all other measures. It just happens to be that some of the dependencies are out of date, and they continue to get out of date the longer that the system is around. So that really kind of gets me to the problem of how do we make this problem more visible? And one way to do that is to start talking about dependency freshness. And so what is that? That sounds like a made-up term, and it is made up. It was coined by Joel Cox in a paper that he wrote to kind of quantify how out of date a system's dependencies are. The idea being that the more fresh your dependencies are, the closer to the recent versions they are. And in his paper, he kind of goes into a couple of different ways that you can measure freshness. And I like to think of it as like brushing your teeth. You know, with the goal being that we all want to have minty fresh software. We want to have you know, software that's clean and up to date. And I think like the brushing your teeth as a metaphor is pretty useful, because the longer it's been since the last time you brush your teeth, the less fresh your breath is. And you don't have to brush your teeth every hour. You don't have to brush your teeth, you know, every minute. Like that would be kind of overkill. So I do think that's one thing I like about this metaphor. But you know, twice a day is a good habit for brushing your teeth. Some of us brush less often than that. Some of us brush very, very well, and some of us don't. And those of us who don't brush very well, then we encounter the consequences for that. And just like with brushing your teeth with out-of-date dependencies, there are real consequences. But the consequences really vary, and they vary depending on whether or not you're a developer or whether or not you're a manager on a team. So for developers, let's list these out. So systems that have out-of-date dependencies start becoming harder to work with. And one of the ways that they become harder to work with is that documentation for the version that you're using becomes harder to find. Anyone who's ever worked on something like Angular, or there's another good example the other day that I'm blanking on. But like when you go to search for information on that library, what the information you're finding is for the most recent version, and it becomes ever increasingly difficult to find documentation for the version that you're using. And then as the version that you're using becomes older and older, support becomes lacking. People are joining the community and they're learning the latest version of that dependency, while your team is still using an older version of that dependency. So then the people who you can talk to who understand the challenges of working with the older version, it becomes a smaller and smaller pool as people slowly start to migrate to newer versions, and as new people join the community and they work primarily with the latest version. From an organization's perspective, there's slightly different consequences that have to be dealt with. Developers become less productive. This is something we talked about earlier with, you know, things that make the dependencies harder to work with also affect each developer's productivity. There is a significantly increased security risk. The chances that an older dependency has a security vulnerability is pretty high. And there are automated systems that can help you assess whether or not your dependencies have security vulnerabilities. And I definitely encourage everyone to look into systems like that. And if you do detect that there are vulnerabilities, develop a plan for upgrading to later versions. And then there is likely, from an organization perspective, going to be some kind of PR fallout or loss of customer trust if there is a vulnerability or a breach. Like, you know, we talk about the Equifax scenario or other organizations that have had security breaches. And reading about that in the news really affects our ability to trust that organization. And so that gets us down to like needing some way to make this problem more visible, needing some way to you know, have some kind of diagnostic tool or maybe even a metric such as LibYear. And so one of the things I like about LibYear is that it's easy to measure, it's easy to compute, I find it easy to describe, and it's easy to visualize. And one of my favorite tools for describing LibYear comes from the LibYear website, and it's this cute little webcomic where it has two developers who are talking to each other, and one is like, hey, we should really upgrade. And the other is like, well, how bad is it? Do we need to upgrade? And the other's like, I think so. It's, you know, when comparing two projects to each other. But then they're talking about two projects that they have control over, and they're using LibYear metric. They're able to have a quantified value about, like, this project is 120 LibYears behind versus this other project is only 42 LibYears behind. And so then they're able to kind of, you know, they have a point of comparison. So we can start to think about, like, you know, why LibYear? So it's easy to compute, and we'll dive into the details of how to compute it in just a few minutes. It distills dependency risk into a single number. The number is you know, measured a number of years. And that's what makes it kind of easy to communicate. It's very easy to explain to someone who's not very technical. It's very easy to explain to an engineering manager. It's very easy to explain to a CFO or a CEO who might not have experience working on software systems. And it provides even more value when you start to graph this value over time and see how it's changing and see what kind of your trend line looks like. So let's take a peek at how to measure this manually. So it's relatively simple. You take the latest version of the dependency that exists and you grab its release date. And then you look at the current version that you're using and you grab its release date. You subtract the latest release date from the current release date and you end up with the LibYear for a single package that you're using. And then you repeat that for all the packages that you're using and then add them together and you get your project's LibYear. But doing that by hand is incredibly tedious, and that's why we have computers. So how do we measure it in an automated fashion? You can use a tool such as this LibYear Python application. So if you've got a Python project, you could use like this exact application to measure it. And so here's an example of it measuring the LibYear for the application PySpider. And here it's you get terminal output. It's it gives us the total LibYears at around 70. But again, it's kind of a static flat measure. It lets us know like which dependencies are more out of date than others. So definitely really useful. There is another tool, which is one that I'm working on, which can help us measure LibYear as it changes over time. And I'm calling it Freshly, and you can view it on GitHub. And let's look at the same PySpider example, but this time in a graph. So here we see the way that the PySpider LibYear has changed over time. And if you find yourself curious about whether or not a single dependency has contributed to PySpider's LibYear, you can graph all of the dependencies at once and really see whether or not any one is really causing the trend. And here we see that there's not really any one dependency that caused that great big blip at the end. It seems almost as if it was a network effect. There were tons of dependencies that all got upgraded around the same time. And if we think about what was going on in the Python ecosystem at about this time, between 2019 and 2020, the Python 2.7 was deprecated. And so you likely had a bunch of packages that dropped support for Python 2.7 and came out with new versions that were only worked on Python 3. Or packages that used to support Python 2.7 drop support for it. And so there are a lot of reasons for packages to update around this time frame. And so that's why you have suddenly a bunch of packages that are out of date. And I haven't dug into this particular graph to see if that is exactly why the LibYear blipped at this case, but I think it's a pretty good hypothesis, and it's one that's definitely testable. And that's one thing that I really like about graphing this data is that it can really help with conversations about how things are going. And for the PySpider team, they may look at this and they may say, okay, yeah, that's fine. We know those dependencies are out of date, but it helps them have a conversation about it as like whether or not they're okay that those are out of date or whether or not any of them need to be tackled. Here we can take a look at another example. This is a Feedben, a Ruby on Rails application RSS reader. And here is its graph over time. And we can see here that the team has definitely made some efforts over the years to really drive the value down. So you can see spikes where the value has been pulled down. You can see lots of little areas where the value has been pulled down. So definitely some efforts there, and this definitely looks like a team that pays attention to dependency upgrades and tries to make sure that our dependencies are up to date. At the same time, the general trend line is up. So while they are fighting to keep things up to date, it almost looks like they're losing the battle because things are kind of ever increasingly growing. And so again, we can look at all of the dependencies together to try to see if there is any one dependency that's contributing a really huge amount to that. And again, what we generally see is a huge network effect. It's not really any one dependency that's pulling them up that way. It's kind of all of them together. There's not really any one that's contributing a huge amount. So that is that's kind of the picture that they're seeing. So if they could find some way to more reliably keep dependencies up to date, then that would likely help them. So a little bit about Freshly's future and its mission and vision. So my mission for Freshly is to create tools that clearly illustrate the financial risk of deferred software maintenance. I think it's really important to make it clear how much risk and specifically how much financial risk teams are taking on when they don't have dependencies that are up to date. And my vision is that eventually a system like Freshly isn't needed anymore, that software systems will eventually just be self-healing and out-of-date dependencies will become a thing of the past. I think as teams start to develop tools such as Dependabot and other auto upgrading technologies combined with continuous integration and continuous deployment, that those are technologies and systems that work really well together, and when combined can create this self-healing system for us. So the best next steps for things to do in the Freshly ecosystem to make it even better is to develop a metric that considers security risk. So one of the things that I really like about LibYear is just how easy it is to talk about. And I think it would be even more awesome if we could have a similar metric that looked at whether or not there's a vulnerability in a system. So that's something that I'd like to be able to work on. And that's something that I've been working on, but I don't have anything that's quite ready to share yet. I'd also like to figure out different ways to formulate ways to compare LibYear across projects. So is there different ways to look at these metrics that makes it easier to compare project A with project B, maybe create a recommendation for a project and say that, this project, needs to improve and kind of, start to compute the risk, maybe create a rubric for how out of date things are, and provide some guidance around good values. At libyear.com, the guidance they have is that for an application, it's less than 10 is the goal. And the organization that helped create the metric said that they normally start working with apps that are around 100. And they work on getting them to be less than 10. But I'm also curious, like, what's a good value for a library? What's a good value for a small application versus a large application? Because the more dependencies you have, the more pressure there's going to be on LibYear being higher. And so maybe even looking at average LibYear or things of that sort. So those are definitely things that I'm interested in. And kind of learning about and continuing to dig on this issue. And if you're interested in Freshly and would like to get involved, you can visit github.com/Corgibytes/Freshly. Things that could use improving, adding more metrics. Right now, Freshly only computes LibYear, but there are other dependency freshness measures. There are some in the original paper by Joel Cox that I'd like to add support for. And there are other ways that we can imagine measuring dependency freshness other than the metric that's used by LibYear. And I'd also like to support more software language ecosystems and dependency formats. Right now, there's support for Python, Perl, Ruby, and PHP. But even within those languages, there's not exhaustive support for all the ways that dependencies are tracked within those language ecosystems. So definitely like to continue to make that support even better and add more languages overall to really make this a nice polyglot tool that can help you measure your project no matter what language your team is using. And then really improve the graph quality. Find different ways to compute these graphs, find different ways to measure them, make them more legible and intelligible, to really kind of hit that mission of making it a tool that we can really help easily communicate the risk. So, and just one of the things that I'd really like to leave you with is the idea that auto-upgrading dependencies is achievable. It is something that we can achieve. There are teams who have done it using something like Dependabot and continuous integration, like I mentioned before, can be a great way to achieve this. And thank you a bunch for having me at PGH TechFest. I really enjoyed attending and speaking last year, and it's nice to be back, even in this virtual format. And if you'd like to get in touch with me, here's my contact information. And I've got a little bit of time left, and so I will take some questions if there are any in the chat, and I'll answer them here. All right, well, it looks like there's not any questions. So thanks again for having me. And I'm going to hop over to the networking area. So if anybody would like to chat one-on-one, they can try to find me over there, and hopefully we'll get randomly matched up together. So thanks a bunch, and I will chat with you later.